I'm going to start this next section in the course on key nutrients. Again, at least the first slide with my picture so you know I'm a real person. And then I'll switch to just audio so that I don't block off any of the screen. I think it's practical when we're thinking about a horse's nutrition, once we've considered the gastrointestinal tract, to consider the feedstuffs. But I think a better place to start is with a discussion focused on the specific nutrients that a horse needs. Those that should be included in the horse's ration, but also an understanding of those that are provided by the horse's own tissues or by the microbial population in the hindgut. So I'm going to discuss the horse's nutrient requirements rather than specific ingredients or feedstuffs. Then we can consider which feedstuffs can be used to provide those nutrients, keeping in mind what we know about the design of the horse's gastrointestinal tract. As Andreas Ellis stated, there is no single correct way of feeding a horse, but we do know a lot about what nutrients are required, how you provide those nutrients, which feedstuffs you choose. You have quite a variety to choose from. To give some context to the discussion, I'm going to briefly cover the take-home messages, the most important pieces of information that I hope you take away from this lecture on key nutrients. You can classify key nutrients in a variety of ways, and people do. I'm going to put them into two categories. The first category are those that are essential and must be included in the horse's ration, and the second category are non-essential nutrients, or those that do not have to be included in the horse's ration because the horse's own tissues make them, or the microbes in the hindgut make them available to the horse to use. It can be argued that the most essential nutrient is water. Water and salt are really the only two nutrients that you can reasonably expect a horse to consume on an as-needed basis. Although I'm sorry to say there are certainly instances in which horses don't drink enough water and horses that don't eat enough salt, and to a lesser extent some horses that will actually overeat salt. But in general, you provide free access of water and salt, and the horses can regulate their own intake. Energy is a nutrient typically, or not a nutrient exactly, but we'll lump it in with that, typically provided by forages and cereal grains along with fats. Any of the naturally occurring feedstuffs or supplemental fats providing the energy or calories the horse needs to maintain its body weight or to grow. Minerals are inorganic substances which the horse cannot make itself and therefore must be included in the ration in varying amounts, while the fat-soluble vitamins A and E need to be included in the diet. Non-essential nutrients, those which don't have to be included in the ration because the horse's own tissues, the microbial population will synthesize them, making them available to the horse, are the water-soluble vitamins and some of the fat-soluble vitamins such as D and K under typical conditions. So what is the list of key nutrients? Water, a source of energy, which strictly speaking is not a nutrient per se, as I mentioned before, but we lump it in here. Quality protein, and we'll talk later about what constitutes a quality protein. Minimal amount of fat, separate from its being used as a source of energy or calories. Minerals and vitamins. If we compare the amount of bulk, pounds, of each key nutrient, we can see that water makes up the bulk. Water's in this blue. The most weight that's ingested by a horse each day. Let's say you have a 1,000-pound horse, 1,100-pound horse, drinks 12 gallons of water. If it's eating, dry harvested forages, each gallon weighs 8 pounds. You multiply that out, and it's obviously a huge amount of what the horse takes in every day. I consider water to be the most important nutrient simply because lack of water will kill a horse much quicker than the lack of any other nutrient. And you can see on a weight basis that it comprises the largest portion of any nutrient consumed each day, as I mentioned. I sometimes think that because water is not expensive, mostly it's free, and it seems to be an obvious nutrient, that many horse owners don't think a lot about their horse's requirement for water, don't monitor how much water their horse is actually drinking, and don't think too much about the quality of the water. We'll talk more about water in a little bit. You compare water to that need for energy, which is the red slice of the pie. You can see that it's a smaller proportion on a per pound basis. When a horse doesn't get enough energy, it loses weight and becomes thin. And when it gets too much energy in its ration, the excess calories is stored in the adipose tissue and the horse becomes fat. Because the effects of too little or too much energy in a horse's ration is very easy to see, horse gets thin, horse gets fat, it makes assessment of energy status of the horse fairly obvious. Most horse owners are aware of whether the horse is underweight, ideal weight, or overweight, although those definitions can vary a bit from one horse owner to another, what's too little and what's too much. Energy in this graph is in the red, and it's about, what you see is about 5% of the energy requirement is met by the naturally occurring fats you find in the common feedstuffs, and that's shown here in the green slice of the pie. Then there is protein, and I mentioned quality protein, by which I mean a protein that contains the essential amino acids, essential meaning those that have to be provided in the ration, the essential amino acids in the right proportions and amounts that the horse needs to have in its diet to perform optimally, grow, be athletically active. Protein is represented by the dark purple slice of pie right there. So protein is frequently something horse owners spend quite a bit of time thinking about. As a weight basis, it's a pretty small component of the total. Minerals and vitamins are needed in such small quantities. You see here, make a little arrow, I can. The aqua colored slice of the pie represents the mineral requirement, and the vitamins that are needed make up so small a proportion by weight that they don't even show up in this graph. For many horse owners, they can seem almost unimportant. When you couple that with the length of time that can elapse between a mineral and or vitamin deficiency and deficiency symptoms, it may not be too surprising that the importance of minerals and vitamins are frequently overlooked. They make up a small proportion of the total diet, and you may not see an obvious effect if they're in excess or if they're deficient for quite some time. It makes managing vitamin and minerals a little bit more challenging. Personally, I blame some of the oversight on vitamin and mineral requirements to the fact that we are so used to people foods, our foods, stuffs, that are supplemented by the food industry with vitamins and minerals to the extent that we don't need to worry about a deficiency in our own diets. Milk is fortified with vitamin D. A lot of the other foods are fortified with extra calcium and phosphorus, etc. So it isn't something that we necessarily all think about, at least on a daily basis, and are worried about. I do want to point out that the abbreviation I've used in the slide that you see down here, the lower right-hand side, or left-hand side, the NRC stands for the National Research Council, which has established the nutrient requirements for horses, which is recognized as a standard for the base level of nutrients needed by the horse. And again, I point out base level. However, I should also point out that the latest edition of the National Research Council nutrient requirement for horses was published back in 2007. So it seems kind of dated, but that committee gets together when necessary to integrate new information and new data and write up a new version of the NRC. and the one preceding the 2007 version was written actually in 1989. So we probably still have a little ways to go before we'll see a newer version, a newer edition. Water is needed for many reasons. I've listed just some of them here, mostly related to nutrition and the gastrointestinal tract, since that's our focus in this course. Water is important in the production of saliva, which moistens the feed, allows for easy swallowing, as well as buffering the acidic pH in the horse's stomach. It also contributes to the movement of digesta through the gastrointestinal tract. But what you don't want to think is that water kind of pushes feedstuffs through the tract. So if a horse drinks, it's actually flushing feed through the tract and accelerate a rate so that digestion absorption can occur. When a horse drinks, the water flows quickly down the esophagus and into the stomach, and much of it will flow across the surface of the food mat, that low-density fibrous mat that sits on top of the ingesta found in the stomach, and then exit through the pyloric sphincter, and so doesn't flush feed out of the stomach prematurely. However, water sloshing down through the GI tract, along with involuntary peristaltic smooth muscle contraction of the tract wall, does help move digest along. So water is important in helping digest move along, but it does not accelerate the rate of ingesta movement past the point that is desirable for digestion absorption to happen. The movement of digesta and the role of water in that process is especially important since the GI tract is folded and coiled with regions of changing diameter and 180-degree turns. Remember that? With insufficient water, partially digested feedstuffs can become lodged in the tract. Horses will continue to eat even when the tract is partially or completely occluded until it becomes uncomfortable, which of course makes the situation even worse. Water is important in the chemical reactions of digestion in the lumen of the gastrointestinal tract. Without water, the digestive enzymes could not function, so it's involved in the chemistry of digestion or breakdown of the feedstuffs. Additionally, once digestion has occurred and nutrients are absorbed, they are transported through the body in the general circulation, made up mostly of water, right? Blood is mostly water, and distributed to the various tissues that need them. In instances when the horse consumes certain pathogens or toxic compounds in its feed, the body will attempt to, if the body recognizes it as such, it will attempt to rid itself of that harmful substance by flushing them out of the body with excessive water movement via diarrhea or through urine once the water has been absorbed across the tract wall. So there are times when you have some flushing systems, but that response is triggered by the recognition that this is an undesirable substance that needs to be eliminated. While not directly related to the gastrointestinal tract, water is also very important in the horse in terms of thermal regulation. Nothing sweats as much as a horse, which is important since a horse has a large muscle mass in proportion to its size. The muscles of a working horse generates a lot of heat that must be dissipated to keep everything working well. The dissipation of heat is generally accomplished by the evaporation of sweat. Sweat's mostly made up of water. For all these reasons, as well as others, drinking water should always be made available, since the horse will, by and large, regulate its intake. I'm going to assume that we are in agreement that water is an extremely important nutrient. The amount of water a horse needs is based on the water balance, which is determined by the sources of water available and the water that is naturally lost. The primary source of water depends mostly on what the horse is eating. We typically think of drinking water as the horse's primary source of water, and that is the case when horses are eating dry feedstuffs such as harvested forage or hay and cereal grains. Those feeds are so dry that the horse must drink water to meet their water requirements. However, if the horse is eating fresh pasture, which is itself, the pasture itself may be 70 to 80% or more water, then it gets much of its water requirement that way and doesn't need to drink as much. That's the explanation for the 20 to 85% range that you see in this slide for drinking water. Fed hay, a horse will meet 85% of its water requirement by drinking water, whereas if it's grazing, it would need to drink much less. That difference is particularly striking when a horse is taken off pasture and placed in a stall or a dry lot and fed hay. Moreover, there is a transition period as the horse adjusts to the change in the source of water. Now, what you want to be cognizant of is that horses cannot meet their water requirement by simply grazing vegetative pasture. So while they might only need to drink 20% of their water requirement since they're eating that, they cannot get by without having some access to water to drink. They can probably get by for a short period of time and then get by with suboptimal conditions, but eventually the incidence of paction colic and some of those are going to rise. So horses need to have access to drinking water at all times. As I mentioned earlier, water is important in various chemical reactions that occur in the body. During some of the reactions, water is actually generated, what we call metabolic water, that you see here. While the amount of water that can be generated through the metabolic processes varies by species, approximately 10% of the horse's water requirements can be met that way. While not a source of water per se, it should be kept in mind that the horse's hindgut can serve as a temporary reservoir, hold a large capacity of water associated with ingesta. Water can be pulled from the lumen of the gastrointestinal tract reservoir into the body itself if the hydration of the horse requires it. So if the horse becomes dehydrated and it needs more water, it can pull it from the lumen of the gastrointestinal tract in order to maintain an optimal balance of water in the body itself. This reservoir is a source of water during those periods of time when water is needed, but water isn't immediately available to the horse. This is a natural process. It's a constantly occurring process as water moves in and out of the tract, from the GI tract into the body proper, and from the body proper back into the GI tract. Water goes in and water comes out. Water is lost in the feces. The amount varies by the horse to some extent, but differs more based on what the horse is eating. If on pasture, feces have a lower dry matter content and a higher moisture content than horses that are consuming hay. Water is also lost through the urine and through sweating in order to regulate body temperature. And to a lesser extent, water evaporation is lost during respiration. There are multiple factors that affect how much water a horse will drink, such as water quality, whether it's contaminated with algae or sand or feces of wild animals in ponds and rivers, which decrease the quality, negatively impact voluntary water consumption. The taste of the water can affect how much a horse will drink. If you are a person that has a well water at home, you know that it tastes quite a bit different than city water, and vice versa. The same is true for horses. Water from different sources tastes differently because of whatever's present in the water, and horses tend to prefer the taste that they are most familiar with, like most people. Temperature of the water plays a big role. There have been multiple studies assessing how the temperature of water impacts how much a horse will drink. Overall, horses prefer water that is between 44 and 64 degrees Fahrenheit, which equates to about 7 to 18 degrees Celsius. Horses will drink much less, 40% less, when water is just above freezing. Thinking about breaking the ice on a bucket of water or off the pond in the winter to allow your horses to drink compared to water that is more temperate. They'll drink and they'll stop drinking, but they won't drink as much as they would have if the water was a bit warmer. When it's hot outside, especially if it is also humid, horses drink more. The need for more water goes up even more with physical activity. The horse regulates its body temperature, as we mentioned, when it's hot, primarily by sweating at times. They can sweat a lot, and sweat consists primarily of water. If a mare is pregnant or lactating, water intake needs go up. If a horse is ill, water intake may go up or it may go down, depending on the circumstances. Usually the sign of a horse not drinking is not a good sign. We've already talked about how what the horse eats affects how much it will drink. The differences are due to both the amount eaten and the composition of what is eaten. Horses eating high moisture forage drink less than horses eating dried forage. We mentioned that. Horses eating a mix of grain and hay drink less than horses eating only hay. Think about, we talked about the production of saliva, which is mostly water. That's increased when horses are eating dried forages that require a lot of chewing. An important consideration is whether a horse will drink enough water. You can see in the right-hand side of the slide 3 different ways to calculate how much water your horse should drink. Since they can be pretty fussy, horses can be pretty fussy, and many factors impact how willing they are to drink, the best situation is when fresh, clean, temperate water is always available. Your goal should always be to maximize water consumption. If there's something that interferes with how much water your horse will drink, you need to figure out what that is and eliminate that interference. You want to optimize, maximize water consumption. Even though energy is not considered a nutrient by the strict definition of a nutrient, it is typically the next key component that we consider in the horse's ration. Energy will be used for basic metabolic processes that sustain life. Metabolic reactions require energy to fuel them, and it's used to not only maintain the status of the body, but to meet the increased demands due to growth, reproduction, and exercise or work. We mentioned briefly that when energy in the ration is less than needed for maintenance, the horse becomes thin with a body condition score of 3 or less. You see in this graph, in a region where the amount of energy that's provided is marginal and is essentially too low, the horse becomes thin. A body condition score of 1 would be extremely emaciated, and 3 would be quite thin. If the ration continues to be too low in energy, eventually the animal will starve to death. Enough energy to meet the horse's metabolic needs, but not too much or too little, where the horse doesn't gain weight or lose weight, able to maintain a body condition score of 4 to 6, is by most considered to be just right or optimal. However, if the horse overconsumes calories or energy in excess of its metabolic needs, those extra calories will be deposited primarily in adipose tissue, and the horse will have a body condition score of 7, 8, 9, 9 being kind of the shape of a round ball with little legs sticking out, roll down a hill, it will be fat. Well, certainly not always the case. There have been multiple disorders associated with horses having high, very high body condition scores. Certainly the most prevalent source of calories or energy for the horse is in the form of carbohydrates. Predominantly the structural carbohydrates found in forages, which are used by the microbes in the hindgut. As a byproduct of that use, they generate volatile fatty acids, which can be absorbed and used by the horse as an energy source. To a lesser extent are the carbohydrates found in high concentrations in cereal grains, which can be digested by the horse's own enzymes in the foregut, generating glucose, which can be absorbed as an energy source as well. Fats are found in forages and cereal grains at relatively low concentrations, although you should keep in mind that fats contain 2.25 times as much energy as carbohydrates. So while there is less, they're more energy dense on a weight basis. Fats are digested and the resultant fatty acids are absorbed and can be used as an energy source by the horse. I've listed proteins on this slide, but note that proteins are not an appropriate source of energy. While they are also digested and absorbed in the foregut, the economics of the digestion and utilization process make amino acids an inefficient and undesirable source of energy, not an appropriate option. As I mentioned, fats are a very dense source of energy, containing approximately 2¼ times as many calories on a weight basis as cellulose, which is the structural carbohydrate found in forages, or starch, which is the carbohydrate found in cereal grains. But in addition to serving as an energy source, fats play very important roles that can't be replaced by any other nutrient and so need to be in the horse's ration. We don't usually think about having to take fats into account when feeding horses, and that's because even though fats are a necessary nutrient, the amounts and type of fats required can be met by the fats that occur naturally in both forage and cereal grains, so that supplementation of additional fats aren't required. Dietary fats, those found in typical feedstuffs, also serve as a source of essential fatty acids for the horse. Essential, remember, is the nutritional terms, means that they have to be included in the ration. They can't be manufactured by the horse's own tissues or by the microbial population. The essential fatty acids that the horse needs in its diet are linoleic and alpha-linolenic. They sound so much the same, but I want you to take notice of the difference in the spelling to help you distinguish between them. Using those fatty acids as starting material, the horse's own tissues can convert them into other physiologically important fatty acids that the horse also needs. The presence of fats in the diet also facilitates the absorption of fat-soluble vitamins, vitamins A and vitamins E, both of which are also essential and so need to be part of the horse's ration. Having fats in the diet are instrumental in ensuring that vitamin A and vitamin E can cross the gastrointestinal tract barrier in the region of the foregut and actually enter the body proper. There are instances in which providing supplemental fat, more so than what's found in the naturally occurring feedstuffs that are typically fed, can be a good choice. When it's hot outside and the horse is working hard, it generates a lot of heat, which has to be dissipated. We talk about how much you can sweat. When horses are fed as an energy source, the amount of heat generated as a byproduct of metabolism is less than what is produced by the metabolism of carbohydrates, especially those carbohydrates digested by the microbes in the hindgut. Feeding fat reduces the heat load on the horse. I do want to spend just a few minutes talking about the structure of fats, mainly because of the interest that horse owners have in understanding the omega-3 versus omega-6 fatty acid controversy, which we'll talk about in a couple of minutes. In the upper panel on this slide, you see the general structure of the dietary fat, also known as the triacylglyceride. So here you have a glycerol, carbon backbone, and 3 individual fatty acids that are attached to that glycerol backbone. So you have tri for 3 fatty acids, glyceride, because you're attaching it to glycerol. You also see it referred to as triacylglycerol. So triglyceride, triacylglycerol, depending on the literature. The fat is made up of the glycerol, carbohydrate backbone, to which the 3 fatty acids are attached. When digestion occurs, the fatty acids are stripped off the glycerol backbone and absorbed separately. So what you'll find is during digestion, you'll clip off this fatty acid and then this fatty acid, and sometimes all 3. Sometimes the glycerol fatty acid in the second position is retained. In the lower panel is an image of fatty acids, which are carbon molecules. So each red dot here reflects a carbon molecule attached to each other by chemical bonds, either single bonds, which is a single line, you see here, or by double lines, which represents a double bond. If the fatty acid has only one double bond, it means that fatty acid is considered a monosaturated, while polyunsaturated means there are two or more double bonds. How many double bonds occur and where they occur along the length of the fatty acid determine its characteristics. So here we're just showing you a short piece of a fatty acid. The fatty acids are typically 16, 18, 20 carbons long. Depends on the specific fatty acid that you're looking at. So how many double bonds and where in that sequence of carbons those double bonds occur determine the fatty acid characteristics. Linoleic and alpha linoleic both have 18 carbons, but the number of double bonds differ. Omega-3 and omega-6 fatty acids play important roles in the body. I want to point out that we don't really know the requirement in either absolute amounts or in ratio of the two fatty acids for the horse. Much of the information you find about omega-3 and omega-6 fatty acids for horses is an extrapolation from what we know about other species, and that may or may not be appropriate for the horse. In the upper left-hand corner of this slide, you see a schematic of omega-6 fatty acid, linoleic, has 18 carbons, 2 double bonds. You can see the double bonds actually kind of cause that carbon chain to kink. On the right-hand side is linolenic acid, also 18 carbons. In this case, it has 3 double bonds. 2 of them are in the same location as you saw on the left-hand side, but there's an additional one here, carbon 3, which again changes the shape, changes the characteristics, changes the functionality of this particular fatty acid compared to the omega-6. There's a lot of information on the pathway, so we're looking at the omega-6 pathway, moving down, oops, it's supposed to be an arrow, versus the omega-3. But I want to point out a couple points. One of the earlier steps in both pathways is the use of delta-6 desaturase enzyme, which is going to be limited. So where the controversy comes over in the relationship between the ratio of omega-6 to omega-3 comes with the competition that occurs for a limited amount of desaturase in those early steps. Other aspect of this is that the omega-6 pathway generates series 2 prostaglandins. As an example, prostaglandin E2 versus the prostaglandin in the 3 series produced through the omega-3 pathway, where you see, for example, prostaglandin E3. E2 is a potent mediator of inflammation, while PGE3 in the series 3 pathway is a much less potent inflammatory mediator, and its production happens to be a very low efficiency. So the controversy surrounds just how much importance, if any, depending on who you talk to, should be placed on the ratio of the omega-6 to omega-3 fatty acids in the horse's ration, how much importance should be placed on the absolute amount of linoleic and alpha linoleic acids in the horse's ration, as well as how best to provide the essential fatty acids. We really don't know the answers to those questions until a lot more research is done. Let's switch gears now and talk about protein in the horse's ration. When we think of protein, it's easy to think that proteins are all the same, or that they're consistent or fairly uniform. However, while there are common characteristics across all proteins, there are tens of thousands of different proteins in the horse's body. The proteins relevant to horse nutrition are made up of 22 different amino acids. And the easiest way for me to think of it and therefore to talk about it is as if each amino acid is a separate letter in the alphabet. In the English alphabet, you arrange the 26 letters in different orders to make different words. The number of words can be made up from just 26 letters, according to the Oxford English Dictionary, is more than 170,000. Then, of course, you can arrange those words differently to make different sentences. And then you can arrange the sentences into different paragraphs. And paragraphs, well, you get the idea. Proteins are the same. There's a seemingly endless possibilities when proteins are made, limited only by the number of each type of amino acid that is available, and of course the genetic signal to construct that particular protein. Link one amino acid to another. So you have one amino acid here, serine, linked to threonine, linked to glycine, linked to arginine. So one amino acid linked to another, and you create a primary structure of a protein. In this case, it would be like a word. You put the letters together, and you make a word. That can then be combined with other primary protein structures to form secondary, tertiary, and finally quaternary structure of a protein. And that would be comparable to words and to sentences and paragraphs and essays or books, right? So, kind of a simplified explanation. But what that means is that what happens when you try to make words, you don't have enough of the letters. Think of the word Scrabble. You don't get some of the vowels you need or some of the consonants you need for the word you want to make. So you can't make that word. You get no points. Similarly, if your horse doesn't have specific amino acids it needs to make a particular protein that it needs for its body, it can't make it, even if there's an excess of other amino acids available. So you don't convert from a glycine to an isoleucine. That doesn't happen. You can't convert from a phenylalanine to a threonine. That doesn't happen. Each of those has to be provided so they can be linked in the sequence that you see here to make this particular protein. Also, you notice that there are 1, 2, 3, 4, 5 arginines in this particular protein. And maybe you call this one 6 down here. We'll call it 6 arginines. But there's only one isoleucine and 1, 2, 3, 4 glycines. So it's not only the absolute amount of each individual amino acid, it's the ratio between amino acids that determine whether a particular protein can be synthesized or made. So if your horse doesn't have the specific amino acid it needs to make that particular protein, it can't make it, right? Even if there's an excess of some of the other amino acids, if there's a deficiency of some, it comes to a screeching halt. It's limiting. You have a limited amino acid availability. Think of too many consonants and no vowels in Scrabble. You're not making too many words. So where do the amino acids the horse needs come from? Some have to come from the diet. Those are the essential amino acids. Some can be made by the horse using pieces of the essential amino acids that were in excess. The ones the horse can make are known as non-essential amino acids. Then there is the in-between category of semi-essential or conditional amino acids that need to be in the diet under certain circumstances or conditions. Maybe when there's an increased demand for an amino acid that can't be met by the synthesis of the horse itself, or if the precursor to the amino acid is in too short a supply. But usually we think of it as essential or non-essential, and this semi-essential is under certain unusual circumstances. That brings us to the concept of protein quality. Quality protein is one that contains the amount and ratio of amino acids that are needed by the horse. So it's not just how much, but they have to be in the right ratio so that it can be combined in that ratio to be used for the proteins the horse needs. Ideally, the protein would have just enough of the essential amino acids and in the correct ratio or for maximal utilization, with none left over to be managed as an excess or as a waste. I need to tell you right now that we don't know the horse's requirements for individual amino acids, which really hinders our ability to design a horse's ration, so we can't necessarily pick out the ideal or the optimal protein source because we don't really know what the requirements are. There are researchers working in that area to try to find out the answers. Just how much of each amino acid does a horse need, and what is the ratio between amino acids that optimize that amino acid utilization. What we do know, based on somewhat limited research, is that the essential amino acids that are most likely to be rate limiting, in other words, those that are most likely to be insufficient or deficient in the common feedstuffs that horses are fed, would be first, lysine is the first rate-limiting amino acid, methionine is the second rate-limiting amino acid, and threonine is the third rate-limiting amino acid, or lysine's most likely to be in short supply, followed by methionine and threonine. Does that mean you have to supplement those amino acids? Not usually, but sometimes. So why not usually? Because most forages and cereal grains contain enough lysine, methionine, and threonine to provide more, and providing more isn't beneficial. But I said sometimes they do need to be supplemented. An example would be in which supplementation of lysine and methionine and threonine would be recommended for young, rapidly growing horses that can't make efficient use of the forage component of its ration until its gastrointestinal tract is mature. Or you might have an adult horse if the feedstuff contains low quality protein. Say they're being fed corn stalks as a source, so the protein quality is poor, probably the digestion absorbability is limited. Then you might need to provide some supplementation. As a general rule, for the adult horse at maintenance or light work, you're feeding forages to meet the energy requirement. You're probably feeding enough protein to meet the lysine, methionine, and threonine requirement of those animals as well. Proteins are used to build, maintain, and repair the body's tissues. Proteins are involved in every single cell structure. As a horse grows, it consumes the amino acid it needs, makes the other amino acids that are also it requires in order to make the proteins necessary to maintain its body and extra proteins for growth. It's also necessary to replace proteins in the body, so that the need for protein is a continuing process throughout the horse's life. Proteins that last the longest need replacement less frequently, while those that are more short-lived have to be replaced more often. So we know the horse needs protein in its diet to provide the essential amino acids that it can't make on its own. Until we know more about the individual amino acid requirements, we rely on the crude protein as an indicator of protein content without regard to the actual amino acids. Crude protein is an estimate of total protein based on the amount of nitrogen present. Since all amino acids contain nitrogen, you can see the presence of nitrogen here in this amino group. That's common to all amino acids. You can calculate that nitrogen makes up about 16% of the amino acid structure. And based on that, it's possible to measure the amount of nitrogen in a feedstuff and then mathematically estimate the amount of protein in that feedstuff. In the process, we're making different assumptions because we don't have all the specific information we need to be more precise. Not knowing the amino acid requirement, the tendency for most is to make sure we provide a lot of protein, hoping to meet the individual amino acid requirement. Usually that approach doesn't take into account that proteins from different sources have different amounts and ratios of amino acids. Think of it as the differences in terms of quality. You might have a lot of protein, a lot of crude protein, providing a lot of amino acids, but if that protein is made up of predominantly just a few amino acids, the other essential amino acids probably aren't being provided. Think of it again using the Scrabble game as an example, where you have a lot of the letters X, a lot of the letters Y, a lot of the letters Z, but not much of any of the others. You have no vowels. You're not going to make any words. If you only have 3 or 4 predominant amino acids in your crude protein, you're not going to make a lot of the proteins necessary for the horse's body. But let's say you make a good choice and are feeding quality protein that has the amounts and ratios of the amino acids that your horse does need. How much of that do you feed? Right? We don't know. Typically, the response then is to overfeed, overshoot that mark, because we don't know where the mark is, and we want to be sure we're providing enough. So you ask yourself, what happens to that excess protein that the horse doesn't need and therefore doesn't use? Excess protein is not stored in the body for later use. That doesn't happen. Instead, there are two fates for excess protein. The amino acid is stripped of its amino group. So again, come back to this kind of standard amino acid structure where you have an amino group, you have a carbon backbone, and then you have this R group, which I didn't mention before, but that is the portion of the amino acid that is different from one amino acid to another and gives it its individuality. But if you have excess amino acid, what's going to happen is this amino group is stripped away. It may be used to be added to a different amino acid carbon backbone, and therefore can create a non-essential amino acid. So an excess of an essential amino acid could be stripped, or really the excess of any amino acid could be stripped of its amino group and then put on the backbone, the carbon backbone of a different structure to create a non-essential amino acid. That's how non-essential amino acids are created and therefore don't have to be fed. So you can strip the amino group off and use it to create a non-essential amino acid, or it can be stripped off and then excreted in the urine. So it can be used to make non-essential, or it can be excreted as urea in the urine. What's left, the remaining structure, the carbon backbone, depends, what happens to that depends on which amino acid we're talking about. It can be, because we also have this R group involved. So it can, the variable group, so it can be used to make, in some instances, it can be used to make fatty acids, which that excess fatty acids will be stored as adipose tissue and contribute to the fat of the horses. Or it might be used to convert it over to glucose and can be used as an energy source. Again, it depends on which specific amino acid is in excess. So while the backbone of the amino acid can be used as an energy source, to do so, because of that process, you have to strip the amino group off and get rid of that, and then you have to process or metabolize the backbone along with the R group and convert it into another form to be used. It's really not efficient or ideal. So if an animal is starving for energy, if they're receiving too few calories, then the horse's body will use up stores of the carbohydrates that are stored as the form of glycogen. It will use up forms of fat that are stored in the adipose tissue. But if that is not sufficient, then the animal will also deplete its own protein, predominantly skeletal muscle. So if you see a picture of an emaciated horse, one that's essentially starving, it has no visible body fat, and it is has lost a lot of muscle mass. So those can both be catabolized in order to provide energy. Again, not an efficient way to provide energy, but it's something the horse can do under dire circumstances. So protein is not recommended as a source of energy, and excess protein, if you know this is in fact in excess, is not recommended because of the metabolic demands that it places on the horse's body. Minerals and vitamins are next on the list of key nutrients, but before I split our discussion into one on minerals and one on vitamins, there are some general characteristics that they share that I want to cover. You've seen this general figure already, where the y-axis represents animal health and performance. That is obviously a very broad category, and it will vary with the circumstances, whether you have the working horse, a reproductive mare or stallion, growing foal, etc. The x-axis along here represents the amount of particular nutrients that's been consumed in this discussion, either of minerals or vitamins. Starting from having no nutrient, should be here, what you see is that if a necessary nutrient is completely absent from the horse's ration, it will die. If the nutrient is present but in inadequate amounts, say in this region, then you might expect to observe some clinical signs that the horse's health and performance has been compromised. So it's deficient. Feed a little more, now you may be in this region, and the horse is better, but isn't really quite up to par. But to diagnose just what the problem is can be quite challenging when there are no overt clinical symptoms. So it's not optimal in terms of health and performance, but it's difficult to pinpoint why that is. When you feed enough, the horse's health and performance is optimized. And that range of what is optimal varies depending upon the specific nutrients. I just made a general classification here, but luckily most vitamins and minerals needed in the diet have a fairly wide range considered optimal. Move further along the continuum, you feed too much. So in this region, you're feeding in excess of what the horse needs. The health and performance of the horse may decline, but again, you're in that marginal region with not evidence of overt symptomology. Clinical analysis might be challenging to pinpoint what the problem is. And then if you feed more, then you're going to be in this toxic region. Clinical signs, overt symptomology will allow you to pinpoint what the problem is. If that's not dealt with, eventually the horse will die. Minerals are inorganic essential nutrients in that they must be provided in the horse's ration. The horse cannot make any minerals. Minerals are used for many, many different functions. They're involved in building and maintaining and repairing tissues. The most obvious example and the most abundant example would be the mineral requirements for bones. There's a tremendous amount of calcium and phosphorus, and to a lesser extent other minerals making up the mineral component of bone. But just like all tissues, bone tissue has to be maintained. Approximately 10% of the bone is replaced every year, even as an adult that is no longer growing. So as bone mineral is lost, it needs to be replaced. Always keep in mind the balance that is dependent on the ongoing processes of synthesis and degradation. Minerals play key roles as cofactors of enzymes, as components of hormones, regulation of nerve and muscle function, as well as regulating through osmotic pressure, body fluids, and there's a myriad of other functions throughout the body. Huge texts written on the roles, functions of minerals. The chart on the right side lists the major minerals needed in grams per day, and the category to its right is trace minerals needed on milligrams per day, so 1,000-fold less compared to the major. So the quantity that determines if a mineral is a major or trace, but they are all essential. All of them have to be provided in the horse's ration. If you are feeding typical feedstuffs, for example forages, the forage plants will contain the minerals that they took up from the soil. That's going to be influenced by the type of soil, the particular forage, the environmental conditions that it was growing on, etc. The fact that the minerals are in the feedstuff doesn't necessarily mean that they're available to the horse. Bioavailability determines whether the minerals can be used by the horse. The biggest hurdle in mineral bioavailability is absorption across the gastrointestinal tract wall. The factors that affect absorption across the gut wall include the physiological status of the horse itself. Young stock absorb minerals differently than do mature horses. If a horse is sick, absorption can be compromised. If the horse's nutritional status is compromised, a series of metabolic changes can occur which can impact bioavailability. If the amount of mineral in the ration is substantively lower than what is required, the amount of mineral absorption may increase in an effort to take in as much of that mineral as possible. There are some absorption mechanisms that are responsible for transporting more than one mineral across the gastrointestinal tract wall. If there's an excess of another mineral that shares that same mechanism, the competition may result in an imbalance in what is absorbed, even if the absolute amounts are in excess of the requirement. Likewise, there are substances in the feed that can interfere with efficient mineral absorption. When you are considering maybe some unusual feedstuffs, some alternative feedstuffs, and we'll talk about that a little bit later, you need to take into account and learn as much as possible about the bioavailability of the nutrients that are in those alternate feedstuffs or unusual feedstuffs before you can feel confident that if simply because they're present in that feedstuffs that they will actually be available to the horse. Vitamins are needed in the smallest absolute amount of any of the dietary nutrients for the horse. As such, they tend to be overlooked even though they are critically important. They play key roles as coenzymes in the enzymatic reactions for growth and development and function of all the body tissues. Vitamins can be categorized as either fat-soluble or water-soluble based on their structure. The fat-soluble vitamins include vitamins A, D, E, and K. The water-soluble vitamins are vitamin C and the B-complex vitamins, thiamine, riboflavin, niacin, etc. These categories can be further subdivided into essential and non-essential. Similar to other nutrients we've discussed, essential vitamins must be included in the horse's ration, while non-essential vitamins can be synthesized either by the horse's own tissues or by the microbes in the hindgut. Of primary concern to the equine nutritionists are the fat-soluble vitamins A and E, since they are both essential and always had to be provided in the ration. You notice that I've listed vitamin D as both essential and non-essential, which probably places it, if we're being consistent with the designations of amino acids, more along the lines of a semi-essential or conditional. The conditions under which a horse needs to receive vitamin D in its ration is when it's not exposed to enough sunlight, since vitamin D is formed in the skin when the horse is exposed to sunlight. So if you keep your palomino or your black horse inside during the day so you can preserve its coat color, turn it out during the night in order to give it some exercise, you should be supplementing with vitamin D. If you have a horse that is normally out but now needs to go on stall rest for a prolonged period of time, maybe it's got a bowed tendon, maybe it has laminitis, maybe whatever it is, if it's not receiving probably 6 hours of daylight a day, it probably needs a vitamin D supplementation. In terms of water-soluble vitamins, none are considered essential under typical circumstances. So what might an atypical circumstance be? So if you have an animal that's being treated with antibiotics for an extended period of time, those antibiotics can disrupt the microbe population in the hindgut, causing reduction in vitamin B and sometimes vitamin K production. And really any significant disruption in the microbopulation might be circumstances in which some of the water-soluble vitamins should be incorporated in the diet. There are numerous factors that impact the bioavailability of vitamins, just as there were for minerals. Many of them are in fact the same factors: the health, nutritional status, the management of the horse, whether vitamins are water-soluble and therefore more readily absorbed, or fat-soluble, less readily absorbed, and the diet in terms of the amount of vitamin it contains, as well as the presence of substances that could negatively impact the absorption of vitamins. So we can review the key nutrients. Water, which is critically important, although frequently the amount needed is underestimated. And the quality of water also needs to be taken into account. Energy provides sufficient calories to permit growth and then maintenance of the body weight. Energy coming typically from carbohydrates and fats, and in some circumstances proteins. Fats provide the essential fatty acids and help facilitate absorption of fat-soluble vitamins, while proteins, while we don't really know what the amino acid requirement of proteins are, we kind of tend to fall back on crude protein, which is an estimate of the protein content. There's no storage of protein in the body for later use, so any excess amino acids must be processed. Minerals, all are essential, all are required to be in the ration, and vitamins are divided between essential and non-essential, and in some circumstances, kind of conditionally essential. As we discussed in the beginning, the take-home messages for this discussion on key nutrients falls into two categories. Those that are essential and must be included in the horse's ration, some of which should be provided ad libitum or free choice, while other essential nutrients must be managed so the horse doesn't get too much or too little. Both situations can lead to problems. The second category is non-essential nutrients that are made up by the horse's own tissues or by the microbes, which are made available to the horse to use, unless, of course, things aren't what they should be considered normal.